Thanks, Laura. Is there a laser pointer? Let's see, because I'm going to probably want that. Okay. Thank you, Laura. So this picture here is what happens after one of those chaining treatments in PJ, which Laura was just talking about. Okay, in advance. All right, so... Okay, I'll still be able to use my laser pointer and look behind me. I'll just stick here, thanks. So when we ask the land managers what their goals are with these mechanical vegetation treatments, they'll tell you it's for restoration. So to understand how they think this is restoration, we have to understand what they're trying to restore to. What is the historical natural state of, in this case of this first slide, persistent established Pinyon-Juniper forests. And to understand that, you have to understand the natural fire cycle, which is much longer than you might think, on the tune of 400 to 600 years. And the reason for this is that where these established PJ woodlands end up are usually on these very shallow dissected soils that naturally have super low cover of grasses and forbs, not usually enough to carry a fire. So when a lightning strikes one of these trees and there's enough wind to carry it to the next tree, that's the fire in persistent established PJ woodlands. Catastrophic from crown to roots, stand replacing fires. Okay, what about... Oops, I hit the wrong button. What about sagebrush systems? What's their natural history in regards to fire? Well, it depends on what elevation they're at and their precip regime. So you'll get everything from these lower elevation, like Wyoming Basin big sagebrush communities with not as much bunch grass. And then the higher elevation, such as mountain big sagebrush communities with more bunch grass. The ecological site description that says sagebrush, any kind of grass, should always have bunch grass. And this picture here behind me, this is what the land managers are hoping to get when they restore these areas. Now, we also have situations with both PJ and sagebrush. Remember, these are dynamic communities that evolved over millennia together with ecotones between them. There's also an ecological site description for wooded shrublands with generally about roughly equal amounts of the PJ and the sagebrush. You also have Pinyon-Juniper eco sites that maybe were chained 50 years ago, and so the trees are recolonizing. And then you also have sagebrush communities that, for a variety of reasons, PJ is naturally encroaching. So in these systems, they're not dragging those big anchor chains to rip out all the trees. They're going after individual offending trees and taking them out. And so we, at Wild Utah Project in 2019, we undertook a comprehensive quantitative literature review looking for all the scientific studies that looked at the results of these vegetation treatments. And are the land managers meeting those goals that they claim to have? Well, what are the reasons that they give to justify these treatments? They do them to increase their herbaceous community, to better resemble the predicted or potential natural community. They're trying to create or improve habitat for wildlife. I like this one. In one breath, they'll say, we're trying to restore the historic fire regime. We're trying to prevent catastrophic wildfire. Remember, in established PJ woodlands, the historic fire regime is catastrophic wildfire. They're trying to restore ecological or hydrological function. I'll note that in the 60s and 70s, at least the practitioners were transparent, that they were often taking out the woody vegetation and seeding grasses to make more forage for cows. As it turns out, to meet the goals here above, it's often going to end up with more grasses and forbs, so the cows that are almost always there on the public lands being treated are going to enjoy that new forage. Okay, so back to the literature review. I'll note in this first bullet, we distilled a ton of studies down to 123 that were included in the literature review. I'll note that this past winter, I just updated the lit review with a bunch of new literature on the topic that has come out since 2019. So when I'm talking about 123 studies going into this, it was 2019 plus today. We prioritized peer review research and only included studies that tested for significance between treatments and controls, where the control was either pre-treatment compared to post-treatment data, or a treated area compared to a place adjacent or right nearby. We considered a single response or data point in our summary charts that I'll show you here in a minute to be one instance of an untreated control compared to a treatment. And I'll note that it's possible that one study could contribute more, or in many cases, way more than one data point to the analysis. And an example, there are many, might be you might treat a huge area, compare it to another huge area next door, and in both those areas, there's 4 different soil types. So there's 4 different data points that can go into our analysis. And then we created these vote counting or summary charts where we tallied up the number of individual responses with significantly positive outcomes of treatment, significantly negative results of treatment, or non-significant. And we did this for these different categories. And it's no coincidence that the categories in the lit review basically match those goals on the previous slide that the land managers give for treatment. So let's look at some of the results of the lit review, starting with herbaceous cover after Pinyon-Juniper treatment. In this set of my categorical summary charts, 29 studies contributed 162 data points to that first bar chart for perennial grass, 105 responses for perennial forbs, and 42 responses for annual grass. And I will note the first thing to draw your attention to is how much blue we have, how many times the results of mechanical treatment are just non-significant. Now, for perennial grasses and forbs, in cases where it was a significant outcome, it was almost overwhelmingly positive. And this isn't a big surprise, because if you wipe the slate clean, generally, of the woody vegetation and kind of rough up the soil, put down a grass seed mix, and maybe have a good spring, you're going to end up with a lot of grasses and forbs. However, be careful what you wish for, because if there's any cheatgrass in that seed bank, that'll come up too. And so I'll note in that bar chart, there were not one single case where mechanical treatment of PJ resulted in less non-native annual grass. Okay, what are the outcomes for grasses and forbs with the sagebrush mechanical treatments? Once again, a lot of blue, a lot of non-significant results. In this case, we had 21 studies that contributed 105 data points to the perennial grass category, 99 responses to perennial forbs, and 100 data points to the annual grass bar chart. One difference here in perennial forbs is when results were significant from treatment, this time they were kind of evenly split between positive and negative. All right, so these days we're seeing lots of cases where the land managers and wildlife managers are doing these treatments to help improve wildlife habitat. I'll note that the critters in this slide are pinyon jays who've been petitioned for federal listing because of dramatic declines in their population across their range. So I think you need to be really careful justifying things like chaining of PJ forests. Okay, for this set of summary charts, we had 26 studies that contributed across these 4 categories of small mammals, deer and elk, birds, and invertebrates, 350 different data points. And the response variables for wildlife varied from everything from pellet counts, which are really more of a surrogate for abundance, true community indicators of real abundance, species diversity, and also demographic indicators such as territory size or nest success. Once again, I'll note a lot of non-significant results for mechanical PJ treatment impacts on wildlife. Something that goes against that trend are a lot of significantly negative results for the bird community, and this makes sense if you're taking out the trees that they're nesting in. And then a fair amount of positive, significantly positive responses from the small mammal communities. And this also makes sense when they take out those Pinyon-Juniper trees. They don't often cart them off-site. They usually gather them in these slash piles. Sometimes they burn them, sometimes they don't. But they'll usually, I think, create good nest sites for small mammals. So this slide I borrowed from our colleagues Bombachi and Petjar, who did a very similar quantitative vote tallying lit review of the impacts of PJ treatment on wildlife. And here, instead of grouping responses by small mammals or birds, well, they did that too, but in this slide, they grouped them by guild. So here are all the species considered generalists, including ungulates and all mammals and everything. So I'll note that for the woodland chart there, there's a lot of negative, significantly negative responses, and this makes sense because this category includes PJ obligates whose trees have gone away. And then on the other side of that coin, kind of the middle bar chart there, these are the shrubland obligates who are going to probably do just fine if the PJ trees are taken away. So I like the way that they summarize their data. All right, what about wildlife responses to sagebrush treatment? I'll note that this chart doesn't include sage grouse. Sage grouse is coming up next. There's just so much study on them. We did them separately. Here, there were only 5 studies we can find. They contributed 38 responses, and that's why here we just lumped all the wildlife together. Again, the main outcome is non-significance of these studies and their impact on wildlife, but there's a good amount of positive, significantly positive effects of the treatment on wildlife. And I think this is because out of those 5 studies, a lot of those species were birds and lagomorphs who ostensibly are taking advantage of that flush of herbaceous growth after treatment, eating it, the actual growth and the seeds. Okay, now on to the sage grouse. Here I broke it down. This is not PJ ecosites versus sagebrush ecosites. Both the left and the right bar charts, they're sagebrush communities, but on the left one, there's PJ encroachment that is being taken out, and on the right one is just traditional sagebrush removal and treatment. And so looking at the PJ one on the left, there's no cases from the literature where if you take out the PJ in occupied sage-grouse habitat that there is a negative effect. And this makes sense because it's well known that sage-grouse do not like to hang out near any trees because that's where the raptors and predators can be that will go after their nests. So more non-significant results and more negative results when you're taking out the sagebrush, again, which makes sense. All right, we also looked at soil responses to PJ treatment. There was only enough literature to only look at the PJ removal. There wasn't enough studies that look at sagebrush removal and the effect on soils. Here we had 14 studies that collectively put 281 responses into these two charts. And most of the studies looking at soil variables were concerned with the amount of soil that is leaving the site with increased erosion that often happens after these treatments with these large backhoes and tractors and mechanical things that are messing up the soil. So once again, mostly non-conclusive, non-significant results. And what about hydrological variables? You know, you often hear that the reason we're treating this site is that there's too much PJ and they, you know, suck up all the water and don't leave enough water for herbaceous vegetation. So they're looking for improvements after they take the PJ away. And in this chart here, there were 12 studies that together contributed 213 responses to these two bar charts. And this is sort of interesting here because they did find a decent amount of significantly positive effects of the PJ treatment to soil moisture. Interesting, the flip side of that you think would be infiltration rate, where it's mostly inconclusive. But I think the basic thing that's happening here is, you know, they're really disturbing the soil with this machinery. And if there's cryptobiotic crusts, they're gone. And in these highly dissected shallow soils, if there's not cryptobiotic crusts, it's not being filled by grasses and forbs. Sometimes it's these sort of mechanical, physical crusts. Either way, it's easier for water to infiltrate and get down into the soil and moisten it if those crusts are gone, which is what happens with these treatments. How am I doing on time? Oh. Okay, great. I just want to kind of wrap up with a huge issue that we knew going into the lit review and was confirmed going through, you know, the 123 studies. There's a huge confounding effect of livestock grazing with implementation results and success of these treatments. And, you know, the bottom line is they're saying we need to treat these areas because they're depauperate of grasses and forbs, because there's too much encroachment of PJ. The forest is too thick. It's taking up ecosites that would be used by grasses and forbs. The sagebrush is too dense and big and decadent, and again, not leaving enough room for grasses and forbs. Well, cows grazing the site are also reducing your grasses and forbs. And if you didn't graze the place forever, maybe you wouldn't need to treat it. And so, you know, the obvious way as a scientist, and any scientist should see this, is to put together a four-way experiment where you have a huge area that you treat, and next door to it is a huge area that you don't treat. And in the treated area, you put a fence down the middle, and then you graze, you know, this part of it, and same on this side. And so post-treatment, you can compare treated grazed to untreated grazed, and treated ungrazed to untreated ungrazed. That's your classic four-way design. This is how you isolate the confounding variable of cattle grazing and these mechanical vegetation treatments. Out of 123 studies that we reviewed for this lit review, exactly 7 controlled for grazing in any meaningful way or at all. And so we closed the lit review with recommendations and data gaps, and obviously the post-treatment cattle problem is very prominent in those recommendations and these other bullets too. And I'll note that they really need to monitor for more than 1 or 2 years post-treatment, especially if they're deferring the grazing post-treatment for 1 or 2 years, and that's when they're doing the monitoring. Okay, so anyway, all right, that's all I have.
Great, thanks, Allison. Great, thank you. Our next speaker is Arnold Clifford, and he is the head of Carrizo Mountain Environmental Consulting in Baclabito, New Mexico. Arnold is a very accomplished polymath, and he's in high demand throughout the US as a speaker on botany, geology, history, ethnobotany, and rare plants, and specifically, especially on the Navajo reservation where he lives. He also mentors Navajo students by teaching them natural history and field skills. He oversees the burgeoning Carrizo Mountain Herbarium, and he's always on the lookout for donations and mounting paper, labels, and herbarium cabinets. And in his spare time, he wrangles sheep and horses and listens to bluegrass music. So I am thrilled that we were able to get him here because he is a wealth of knowledge, and also as an Indigenous person, he represents perspectives that we are sorely lacking almost throughout our work. So let's give Arnold a warm hand.